Welcome to Deciphering Android Design Principles with Now in Android. In this series, we'll delve into Android development best practices using Now in Android. In this video, we'll take a detailed look at how to utilize coroutines and flows. In particular, we'll focus on how to use coroutines within state holders. First, let's review the basics of state holders. In Now in Android, state holders generate and hold the data displayed in the UI. When the data changes, UI elements are redrawn to display the latest information. When generating UI state, it's necessary to process it without blocking the UI thread to avoid hindering screen rendering. Let's see how we can utilize coroutines in state holders to achieve this. Let's look at an example of code when a keyword is entered in a search screen. We will prepare a mutable state flow for search keywords within the search view model. This is a type of flow for managing state. It holds a single state, and when there's a change, it notifies all collectors. This flow has the characteristic of continuing to hold the state even if there are no collectors. It's very suitable for purposes like managing search keywords, where you want to reflect value changes on the screen. When publishing to the UI, we provide it as a state flow, which cannot be updated, using the state_flow function. I believe that in the actual Now in Android code, the saved state handle is used in the following way. The saved state handle is a class that allows you to hold UI state in a key value format without worrying about state changes like screen rotations. This class is used to update, notify, and retain search keywords. In reality, it plays a similar role to the mutable state flow we saw earlier. Here's the English translation of the Japanese text. Next, we'll look at the code for displaying a snack bar when the network is disconnected. We collect is offline, which indicates the network connection status. We use launched effect to monitor is offline and display the snack bar only when offline. The point to note here is that even for one-time events like displaying a snack bar, we use a state flow and monitor the condition for execution. On the other hand, we do not use channels or shared flows. These are flows that don't hold values and have a mechanism for consuming buffered data, but they might not allow you to collect events in the UI. Next, we will look at converting flows using state_in. State_in is a method for converting a non-stateful flow into a state flow. As explained earlier, a state flow holds a single state and notifies collectors when there is a change. In this code example, we are converting a non-stateful flow returned by a user data repository into a state flow. Because it is a flow for holding state, you need to specify an initial value to hold. Furthermore, the started argument sets the timing for when the state flow becomes active, while subscribed activates it only while the UI is displayed. More precisely, the state flow stops if it is no longer collected for the specified duration. Specifying lazily means that the state flow will continue to operate if the user may return to the UI. In other words, the state flow will continue to operate if it exists in the navigation backstack or is in a tab that is not on the screen. Finally, let's look at flow aggregation using Combine. Combine is a method that monitors multiple flows and generates a new flow whenever any of them is updated. In this example, Combine is used to monitor the necessity of onboarding and the topics being followed. If either of these changes and onboarding is deemed necessary, display data is generated from the followed topics. Furthermore, the generated data is transformed using state_in into a type that is easy to monitor in the UI. In this way, aggregating multiple flows allows you to maintain flows at an optimal granularity while transforming them into UI states that are easy to use in the UI.